Hello, welcome again to another edition of James' Chris Science videos, where today we're looking at current in parallel circuits. Previously we looked at current in series circuits, and we looked at the fact that the current stays the same at any point in the circuit, and that if you keep adding components, the current goes less. Series circuits, we've got something different happening. So what we've got to do, here I've set up a very, very simple parallel circuit, where you can see we've actually got one circuit that goes round here, and we've got one circuit that goes round here. And with parallel circuits, the secret is to treat each of the individual kind of parts of the circuit as a single circuit. And that's going to enable you to kind of make sense of what's going on. So what's going on here? Well, here we've got one light bulb, and that's got a reading of 0.25 amps. So that means that's going through. Now, if you remember back to the previous lesson, 0.25 amps is what one light bulb with one cell takes. So that is just reading it as though it's a light bulb and one cell. The second one here, each light bulb slightly manufactured slightly differently. This one's got a reading of 0.26 amps. And so that's very similar. The two of these are pretty similar. And you can see the brightness of the bulb is the same. And they're as bright as they would be with one light bulb. So where the two circuits join up, you can see this line here, you can see it adds up here to 0.51 amps. So that is an addition of 0.25 and 0.26. These two lines add up and join together here. Imagine it like a river. The river splits up into two parts. The two parts are going to be half of what that part is there. So, prediction time. What's going to happen then if I put another light bulb going across this way here? So, have a think about it for a second. What's going to happen to each of the readings? So, let's have a look. Let's put that in here, that in here, this in here, this in here. And we'll see, first of all, these two readings have stayed exactly the same, except for now, this one here has gone up. Ignore the minus, that's just we've put them in the wrong way around. So minus 0.75 is an increase of 0.23. That means the current through here would be 0.23. And those three light bulbs all light up the same. Now, there are some big advantages for parallel circuits and why we use them. First of all, you can see that the brightness stays the same. When I did a series circuit and I did three light bulbs together, then it hardly lit up at all. There was no brightness. This one, the brightness is the same. Second advantage, if my circuit breaks, if I break that light bulb, you can see the three light bulbs, the other two light bulbs will stay on because the electricity can still get round back to the cell. It hasn't been blocked. In a series circuit, if one breaks, they would all go off. So parallel circuits are quite useful. And what you've now got to do is to work out the different currents in each of the situations. So similar to last time, what I'm now going to do is I'm going to have a sheet of different parallel circuits where I would like you to work out the different currents. Again, I will hopefully be online, put questions in the comments and so on if you have any questions about how to do them. I will also, at the end as an extension, I'm going to start asking you some questions about what happens if I combine series and parallel circuits together and see if you can work out what to do if I've got both in the same circuit. Thank you very much. The next question, the last word of today is represents.